Hi everyone, welcome to our Atmaya Electrocrats channel. In this video, we are going to discuss about a frequency modulation and demodulation of an 4 semester communication laboratory 1 according to an video syllabus. I am Chandrasekhar P, working as an assistant professor in Department of Electronics and Communication, ATM College of Engineering, Mysore. The first and foremost, we are going to discuss about a frequency modulation and demodulation of a circuit using an Scilab. So this experiment can be do in an MATLAB also, but we have using an Scilab which is an open source. And also I have shared the MATLAB code. You can be used as a practice or an assignment, and you can execute if you are available with a MATLAB tool. The main aim of this experiment is to study the process of frequency modulation and demodulation and calculating the depth of the modulation by varying the modulating voltages. The objective of this frequency modulation and demodulation is to perform the modulation and demodulation process using an Scilab and to analyze the frequency modulated and demodulated signals in the domain, time domain and a frequency domain, to plot the frequency spectrum of an frequency modulation and demodulation using an Scilab. Before going to this procedure or a code of this, first we'll understand what is a frequency modulation. The frequency modulation, which is shortly called as an FM, is a type of angle modulation in which the frequency of a sinusoidal carrier wave deviates from a center frequency by an amount proportional to the instant value of the message signal. The center frequency is also known as a carrier frequency in an frequency modulation, and the frequency modulation can be expressed using the equation for angle modulation, that is SFM is equal to AC, which is called as a carrier amplitude. So AC into cos of 2 pi fct plus kf am divided by fm into sine 2 pi fm t, where AC is the carrier amplitude and fc is the carrier frequency. Kf is the frequency deviation constant, which is measured in hertz per voltage, and fm is the frequency of the message signal. The frequency modulation is a nonlinear modulation process in which each spectral component of the baseband signal give rise to one or two spectral components in a modulated signal. These components are separated from the carrier by a different frequencies equal to the frequency of a baseband component. Most importantly, the nature of the modulators is such a that the spectral components which produces decently on the carrier frequency and the baseband frequencies. The spectral components in the modulated wave form depend on the amplitude. The modulation index for FM is defined as it is the ratio of maximum frequency deviation to the modulating frequency. That is, MF is equal to maximum frequency deviation divided by modulating frequency. The block diagram of modulation is where the modulating signal, which is generated from a function generator, is fed into an circuit of FM modulator, and which is going to produce a frequency modulation output. The demodulation is the reverse process of a modulation technique, where the modulated signals which is generated, the output of an FM modulator is an input for the FM demodulation, and we are going to obtain or recover the original message signal what we have been fed as an input from the signal generator. Next, we'll know what is the importance of the frequency modulation. The amplitude of the frequency modulated wave does not get affected. That is the one important. Frequency modulation decreases the noise, hence there is a significant increase in signal to noise ratio. We can also reduce the noise by increasing the frequency deviation. It also reduces the interference by adjacent channels through the guard bands. It operates in a very high frequency called VHF. It is resistance to the signal strength variation. It does not require a linear amplifier in the transmitter. Next, we'll see the code of the Scilab. So, where the CLS will stand for the clear the screen, and whatever the content that has been there, it will going to be cleared and closed. The Fs is a sampling frequency where I am going to consider as an 3. Why? Because I have got an equation that f the message, that is m of t, is equal to am into cos 2 pi into fm into t. Here the fm has to know the value and am has to define the value. Hence I am going to consider the fs as in 300 and fm as an input which is going to entered by ourselves, which is going to define the length of it, that is enter the message signal frequency. So the carrier frequency, which is called as an FC, which is also again an input to the modulator. So but when we are giving a value, the carrier frequency should be much more times greater than the modulating frequency. And we need to give the what is the message signal that is going to be amplitude, which is defined by a variable called as an AM, and the input of a carrier, what we are going to give the amplitude, is defined as an AC. So from this all the inputs, now we are going to calculate what is m of t, that is am into cos 2 pi ft. So that is going to be plotted by that is in a graph by using an subplot and the plot. Here the plot we are going to plot between a time and the message. Hence we are going to get an mx, that is the waveform in a x-axis as in time and in y-axis as an amplitude, which is going to define as a message signal, which is called m of t. Next we are going to define the carrier signal generators. So where the carrier signal generators has got an equation AC into cos 2 pi uh, fc into t, and here the 3 1 by 2 is nothing but we are going to plot a 3 windows, that is input, carrier and output. In that, in a first column what we are going to be plotted, that is going to be decided, and as in a second one you can see here it is in 3 comma 1 comma 2, it is in 3 comma 1 comma 2, that is 3 comma 1 comma 1, that is going to be plotted. We are going to divide the screen into three parts. In that, the first part we are going to have a message signal, in second part we are going to have a carrier, that is going to be defined. And next we are going to, after plotting this carrier frequency, next we are going to be do the frequency modulation. So in this frequency modulation we require the a modulation index, which is given by an that is mod underscore index, and that equation is given by fm kf into am divided by fm. And finally we are going to display the keyword called as an frequency modulation, which is given by an equation AC cos 2 pi fc into t, that is a carrier, plus m of t, that is mod index with one sin 2 pi f into t. So when we do this in a third plot, we are going to plot an output, that is a frequency modulated signal. For demodulation technique, so we are going to be considered as a demodulation, so we'll discuss in next. So now we are going to plot the a frequency spectrum for that. So to find that frequency spectrum, we have gotten a command called, that is d is equal to minus p of 2 is to 1 1 is to 2 p divided by 2 minus 1 into 1 by 3. So where we are going to plot the modulations and the demodulations, that is program, that is waveforms in terms of a Fourier transform and then time domain, that is in time domain and then frequency domain we are going to be plot, and we are going to analyze the frequency spectrums of the modulation index. Similarly with that, this is then a sample inputs what we are going to give and what we are going to get as a modulation index, that is enter the message signal as in 2. We'll show in a demo how to run this program, and enter the carrier signal as in 23, so which is much higher than the m of t, and message signal amplitude is 4 and carrier signal amplitude voltage level is in 3 and modulation index is in 8. After doing this, we are going to obtain the output as an like this. This is the output what we are going to obtain. So this is an 1 comma 1 comma 1 plot. This is 1 comma 2 comma sorry 1 comma 2 comma 1 plot, and this is 1 comma 3 comma 1 plot. So depending upon the plots, and this is a frequency spectrum. So according to this we have gotten, that is similar to this, we have gotten a code in the MATLAB. So the same thing, fs fc, we have gotten frequency deviation, and that is nothing but the thing is what, in a MATLAB we have got an instruction, or we have gotten a command which is predefined, that is FM mode and FM demode. So where FM demode will be used for a demodulation of the frequency modulation, and FM mode is a keyword for a frequency modulation. And again this is a plot, that is 4 comma 1 comma 1, 4 comma 1 comma 2, and similarly 4 comma 1 comma 3, and 4 comma 1 comma 4, which is to display the demodulation signal. So this is the output. So this is another method how we can be do the frequency modulation by using a symlink in the MATLAB. Just drag and drop blocks, but we are not going to execute this, but you can do it as an assignment. So you can drop this blocks, and you can be connected, and you can cross verify, or you can check the what is the modulation and then demodulation we are going. So with respect to this, we have gotten a waveform, how our waveforms will looks when we connected the output into an CRO. So what are the disadvantages? The FM cannot cover a large area. The transmitting and receiving equipment of the FM is complex and expensive. Generally, wider channels of a 200 kHz are required for an FM. The antenna for FM needs to be closely placed for a better signal. And applications of the frequency modulations and its conclusions are as follows. It is used in an FM radio and a music. It is used in television sounds. It uses in a satellite and so on. Satellite TVs and so on. So what is the conclusion? What we learn? So communication systems plays a very important or a significant role in our daily lives, and frequency modulation is a process by which the frequency of the carrier signal changes with respect to the modulating frequency. But it is broadly used in a national radio broadcast, satellite TV, sounds, musics, video transmission instruments. It has a various advantages over a amplitude modulation and a phase modulation also, but it provides a noise immunity better than an AM and PM. Compared to that, it offers a low inferences and a high sound to noise ratio. So now we'll go with the hands-on sessions in an Scilab. So before going to hands-on, let me give some brief instruction what is that Scilab is. Scilab is a free and open source course platform numerical computation package and high level numerical oriented program language. It can be used for a signal processing, statistical analysis, image enhancement, fluid dynamics, simulation, numerical optimization, modeling, simulations of explicitly and implicitly dynamically systems, and so on. Symbolical manipulation can be used. Scilab is one of the two major open source alternatives to the MATLAB, and other one being an GNU graphic Octava. Scilab puts less emphasis on syntactic compatibility with the MATLAB and than Octava does but it is similar enough that some authors suggest that it is easier to transfer the skills between the two systems. Now we'll go with the hands-on session in a Scilab. How this Scilab is going to use. So run the Scilab. So when you run a Scilab, click on the a new file and take a new file which is an unedited file. So it is the file which is untitled one is called as an Scilab notes. So in this you need to type it the program. So first line what was it was an CLC which is used to clear the screen and clear the content if it is there any console, and if any program is run, so to close that we have got a command called close. Now first we need to define what is the sampling frequency, that is fs is equal to, let me call it's around 300, and the time period which is going to be calculated as an t is equal to 0 down to 1 divided by sampling frequency fs is double to and 2, and we are going to define then a p which is called as a length of the signal what we are going to use, which is called as a length of a t, that is an time. Next we are going to define the fm, that is a frequency modulation, that equals, which is an input for my, because I have got an equation that is to calculate the message signal. I have got an equation am cos 2 pi 2 pi fmt. So here the input, the fm what I need to be defined to find out the what is the message signal generation, hence I am going to define as an fm is an input, and this input which is I am going to given by myself, that is enter the message signal frequency. Similarly like that I am going to use an fc is equal to input enter the carrier signal frequency So next, so the carrier frequency what I am going to use, it should be the frequency what I am going to give as an input, it should be the carrier frequency should be much more higher value than the FM frequency, that is a modulating frequency. Next I need to define what is an amplitude, modulation amplitude, as an input enter the message signal amplitude. Similar to that, AC carrier amplitude, it's also the same thing, but instead of signal amplitude I'm going to copy down the same thing, just I change the message into an carrier signal amplitude. So this defines the initialization steps. Now I am going to generate a message signal message signal generation. So this is what I am going to be, so I will make it as a command, that is just to clearly understand, and got an equation that is to generate a message is nothing but that is equal to am into cos 2 into pi into fm into t. Let me check if this value doesn't take, okay, percentage p, which will automatically take it. Now I want to plot this signal, so hence I'm going to consider a figure 1 figure 1 and I will subplot, I will divide that figure 1, that is subplot into n 3 categories in the first with the first window. Subplot 3 comma 1 comma 1. Next I will plot time versus a message. Next I need to label the x-axis and the y-axis. So x label, it's an label keyword. I am going to call it as an at time, and for a y label I will call it as an amplitude. And the title for the graph I am going to specify it as message signal. This is an input. And next is what? Next I am going to define the carrier generation. So I have gotten a code, just I will copy the carrier generation part. Similarly carrier, and similar to that I got a next I need to generate frequency modulation generation. Next, after generation of a frequency modulation, next I need to go ahead with the frequency spectrum analysis with respect to time domain, and finally I'm going to represent in an modulated frequencies, Fourier transform modulated frequency. So now my code is done. Next I will save this code. So here I have got an option called save the file. So once save the file, you need to give the extension as an SCI, that is Scilab science file. I will call it as an FM modulation. Save it. So now I will run this. So when I given a run, so it start running a console. In that console I am going to give the signal frequency, enter the message signal frequency as in 3, enter the carrier frequency, I will give it as an 10, much higher than what the 3 times I have given. Message signal amplitude as in 2 volt, carrier signal amplitude as in 2 volt. Now I am going to get what is the modulation index. The modulation index is often 2.66. So once it has been generated, your waveform graphical representation is going to be done. So this is the message signal, this is the carrier signal, and this is the modulated signal. So in this modulated signal, whenever I find the high frequencies, that is modulated high frequencies, that with respect to the carrier, the signal is going to be obtained. That is more number of cycle is going to obtain at a higher frequencies, and then at a low frequency the low cycles are going to be obtained. So this is a window. So and you can measure these values with respect to x-axis and y-axis. So you can see exactly so where it is. And next, if I want to clear the picture, I can use the clear options. So if you want to move object, you can move it. Now next I have gotten a frequency spectrum analysis. This is the frequency spectrum analysis, the FM signal spectrum analysis of the frequency modulation. So the modulation index what I got for this value is at 2.66. Now I will run for the second case with the more higher frequency. Let me go ahead with this another values. When I run this, so again the console I will give it as an 5, and the carrier frequencies I will give it as a 10 times more than that of it. So amplitude is of an 5 volts and this is of an 5 volts. So what is the modulation index? It is an FO. So when I give this, you can clearly see the frequency modulation signal spectrum. So and also you can see the output, which is a combination of that both. So I have gotten a more number of cycles with respect to this. So and I will go for another case. I will run once again. You can see the play button here, execute. I'll give another case. Let me call that as 3 and 23 with an amplitude of 2 volts and with an amplitude of 2 volts. So this will clearly sees the this is an S frequency spectrum and this is the F frequency modulated signal. So if you have any doubts, you can ping this in videos. So thank you one and all.